the first thing we need to make for the power copy is an organized set of inputs, because this knowledge, this power copy needs to be based on some kind of geometry somewhere. So I made a very arbitrary surface to start. I placed 4 points on the surface and then started building everything from those 4 points in the surface. It's a kind of simple place to start. When we go to instantiate this thing, that means our power copy is going to look for 4 points in a surface. So we need to kind of think ahead and be thinking about how we're going to instantiate when we're creating the power copy. I'm going to give you kind of the tools to instantiate, and I know the tools that I'm giving you are going to make points. So we will just build this power copy from 4 points and deal with instantiating later. So we need to make some inputs. So new part. And I'm going to call this right away PW folded panel. Again, make sure you have hybrid design checked, create geometrical set. You don't need, leave the other boxes blank, hit OK. And so I think we even called the pencil a power copy too. We gave that a little prefix, PW. Geometric set.1, we need to make that our inputs geometric set, so right click and properties. Feature properties and call that inputs. And right away, let's make another geometric set for our panel. I'm missing. So to make a new geometric set, I'm going to click the little down arrow and select the second out of the list. And I have geometric set dot 2. Right click, properties, PW underscore folded underscore panel. It's just good practice, in my opinion, to name the power copy the same as the part, especially if you're going to instantiate from document. And let's save it. Now, save location is important, especially if you're going to instantiate from a knowledge pattern automatically later. One thing we're going to have to do on Thursday is make a catalog and point to that catalog when we instantiate. So this power copy is going to get placed in a catalog, and that catalog is going to get called when we instantiate. So we should all have a place in your documents, or on your computer, or on your desktop on your computer where you can save this and where it will stay. I am going to put this, I think I have a place in my documents. File, save as, documents, KU. I'm just going to make a power copies folder. And I'm going to place it right in that power copies folder. So if you guys have a path on your computer, save it. Make a power copies folder and save it in there. Done? Now let's make the inputs. Okay, so activate the inputs. Right click, define in work object. Maybe zoom out a little bit. And let's make 3 offset planes. So offset plane number 1 off of the XY. Make it 5 inches off of that. Offset plane number 2 off of the XY. Make it 36 inches. Offset plane number 3 off of the XY. Make it 72 inches. So now we have 3 planes. I'm not going to go to I'm not going to bother to rename these right now because they're just support planes. They're not going to be used for anything other than the creation of my surface.
What were the
3 values: 5, 36, 72. Here we go. Since we're on the topic of power copies, I'm going to show you another way to make a power copy. It's going to be super simple, and it's a way to replicate geometry in your model. So let's make another geometric set and drop it inside of inputs. Right-click on that and call it spline underscore 01. Okay, now we're going to put 3 points, 1 on each plane. We're going to make 3 points, 1 on each plane. So point, bottom plane, anywhere on the plane, doesn't matter. Point, middle plane, point, top plane. So I've got three points, and I visually know where each one is on each plane. And then make a spline. Spline right here underneath circle. So I'm going to select the spline and then point 1, point 2, point 3. Press OK. Now if you rotate around, you can get an idea of what that spline looks like. Yes. That's a new geometric set. So I've got inputs, plane, 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 spline 1, point, 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 and spline. On day-to-day modeling, I probably wouldn't go through this process to get a spline, but because we're going to power copy it, it's just an example to show you some functionality. Does everybody have the geometric set, point, 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 spline? Okay. If you select that geometric set, select the geometric set, so get it highlighted, go to Insert, Advanced Replication, Instantiate from Selection. You get the little, this is the power copy instantiation window. So we're going to insert this geometric set back into the model. We're going to duplicate it. So right now it's saying, where's the destination for this power copy? I want to put it after spline 01. And now let's say we had 3 different planes we wanted to place these on. We could select the 3 different planes. Let's say we wanted to reverse these and put these on plane 3, plane 2, and plane 1 instead of plane 1, plane 2, and plane 3. We could select these in reverse order as inputs, and it would draw the spline upside down. Or we can just say use identical names, use identical name, and it's going to find each one of those planes. Press OK, and now we have a new geometric set called spline underscore 1 right underneath spline underscore 1. I'm going to rename that spline underscore 2. So right click, properties, spline underscore 2. Yeah? It didn't. Is anybody else not getting it to use identical name? Okay. It should work. If it doesn't, you could cancel and restart, or you could It did not? Did you get the same window open?
Yeah. I know.
Alright, so rename it to Spline02. Hit OK. And now just move these points. So now you've got 2 splines. You just made your first power copy. You just instantiated your first power copy.
Wow.
Alright, pat on the back. Now, move some of those points. Kind of pull them off to the side. But that right there, the very, very basics of a power copy. Dump everything in a geometric set. Dump everything that you need and you know you have certain inputs. You want to replicate it, instantiate from selection, and you're on your way. Now I'm going to kind of sculpt these guys a little bit. I don't like that. Kind of move it around. We're going to make a surface out of these. We're going to make a multi-section surface, which is like a loft. Double click on the point, and then select anywhere in space, and it will start to move for you. If right now, actually, they're going to be overlapping though, one point on top of the other. So it might be easiest to double click it in the tree first, and then click off into space. And kind of line it up. You see how I kind of lined mine up? Making kind of an arch. So see, even for this task, even making the inputs is a mini modeling task. Let me know when everybody gets this like so. And remember, this is just step 0.1. We have more steps to go, so just get it close, and then you can tweak it later. Once you get the curves where you want them, right-click on inputs, make that your work object again. So define in work object inputs, because we don't want to put the surface inside spline.2 or spline02. And we're going to make I'm missing my toolbar. Okay, so we're going to make a multi-section surface. There are 2 ways to make a surface through 2 curves like this. One is a blend, and one is a multi-section surface. Whenever I need to choose between the 2, I'll generally choose a multi-section surface because I like the way you control that surface better. Although, nothing wrong with blend. Blend is great. It has its purpose, but I just like multi-section surface more. So select multi-section surface. You get the definition window. Select spline 1, select spline 2. You'll get one thing you want to make sure is you want to make sure that the directions of the splines match. They should, because we built the second one with a power copy. To show you what happens if they're not matching, I'm going to change that quickly. Say OK. It leads to a cusp. I've got a twisted surface because the directions of the splines don't match. If I change it back and press OK, I've got a nice smooth surface.
you created the surface, was it possible to pull the points then? And
Oh,
build
for
the
sure.
surface?
Totally. Totally. That's why getting the curves in kind of where you want them is a good start, and then you can tweak it later. The one thing I like about multi-section surface, you guys don't have to do this, but look at how, this is one nice thing about a multi-section surface. And this will be a good way to compare two types of surfaces. I'm going to make two lines between the start and the bottom, start points and the end points of my splines. And you see that the surface doesn't match because of the way the surface is interpolating between the curves, between the splines. If I double click on this, I can select these lines as guides. And now I've constrained the edges of that surface to those lines. In my multi-section surface definition, I've defined those two lines as guides to my surface. You don't have to do this now. This was just a kind of to show you different ways to control the surface. Now though, if you think about it, I have bounding curves. I could make a fill subtype, a surface subtype fill. So if I make a fill and I go around and I select these curves, I got something pretty similar, but not exactly the same. If we compare these two surfaces, they're not going to be exactly the same. I would say, actually, if you guys have time later between now and Thursday, because I know you will, play with making different surfaces here, because also I can draw a line between these 2 points, and instead of making a multi-surface section between those two curves, well, now if I want to, I can make a multi-section surface between these lines. There, that's completely different. If I take that that's not my multi-section surface. If I take my multi-section surface and I use my splines as my guides, I just showed you 3 different ways to make one surface, and they all look really similar to another. And I could make the fill. We could do, and we didn't even do the blend yet. Poor blend. Okay, now we've got a blend. Now that's 1, 2, 3, 4 different ways to make one surface. And they're all pretty similar. So I'm going to delete back to where I was because I just want the very first multi-section surface. Do you want to keep those lines?
I mean,
If you made them, you can keep them. You know, I'm going to pull them out just because I didn't ask everybody to do it. Okay, so now we've got this surface. The surface is going to be used as an input to the power copy, so we should give it a name. And since it's a power copy, we want this name to be super generic. We just want to know basically what type of geometry it is. So I'm just going to call it surface. That way, when we insert this power copy into the next model, when it asks for a surface, we know that it's looking for, well, okay, if we wanted to be a little more specific, we could call this our base surface. This is the base surface that we're using to support our power copy. So I'm gonna call it base surface. Base surface. And enter. Now we need to make our 4 corner points. We're just going to drop them on the surface, but one thing when you're building a power copy, you want to make the framework upon which you set your power copy flexible enough to test the behavior of the power copy. Otherwise, it could and likely will break when you instantiate it the first time. So in order to test this power copy, I want to make a point on the surface that all of those other 4 points are referencing. So when I move that central point, the 4 points referenced to the surface and that point will move with it, thus allowing us to kind of flex the power copy and test its performance. So point number 1, select the point, select the surface, and we'll just put it anywhere. Press OK. So that's kind of hard to see, but that's our base reference surface that's not going to be used in the power copy, but it's going to be used to test our power copy. Now we can make 4 points. So point number 1, select the surface, and now in reference, we don't want to reference the middle of the surface, we want to reference that reference point that we just created. Okay? Now the new point on the surface is going to be referencing that point location, and when that reference point moves, this point is going to move on the surface relative to that one. Put it within, now we have to have a general idea of scale of the power copy. If we're going to, let's say this thing is going to be a 12-inch square. Let's put this 6 inches or so from that point. You see the distance up there moving when I move it? Oh, as I move it away from the point, I'm extending that distance. Let's put it maybe 6 inches or so, 7. We can fine tune that later. And we're going to call that point RT point, right top point. Okay? So right click, properties, RT_PT. Now when we insert the power copy, when it asks for RT/PT, we know it's the right top point. Let's do that same thing 3 more times to create the RB/PT, LB/PT, and LT/PT. So select the point, select the surface, put your highlight this reference point, and then select that point again. Now we should be referencing that point as we move the current point on the surface and place it 5 inches or so from that reference point. What we're doing is we're going to build kind of a little rectangle or a little square around that central point. So we've got RT/PT. We just created a new point. Let's rename that one RB/PT for right bottom point. And now I'm going to make 2 more points. There we go. I made my LB/PT. And LT/PT. Now, when you select that reference point, that first reference point that you made, maybe let's rename that ref point just so it's clear in the model what that is. So mine is point.7. Right click, properties, ref_PT. When you click ref point and you move it around on the surface, those other 4 points, because they're referenced to that point, will move with it. They're going to retain that relationship relative to the ref point. Now we can build our power cap and we can test it down here on the surface, test it over here, test it over here, test it over here. Make sure that it's working in all of these areas of the surface so that when we go to instantiate it on another surface, there's no surprises. Questions? Nope. And because everything is parametrically linked back to these planes, we can also test it by moving these planes, or moving the splines, or any of that fun stuff. So that's it for the inputs. Everything that we make contained within the power copy is going to be based on those 4 points on the surface. So we can collapse inputs, and let's make a new geometric set and call it construction. And drag that into the PW folded panel. Because we're not going to model, just like you saw in that other power copy example, we're not going to model straight in that geometric set. We're going to try to keep it organized, which is incredibly important for a power copy, because you're going to replicate this thing 100, 200, 300, 4,000 times. You want to take care that this thing is very clean and very organized. Otherwise, you're just going to create 4,000 point.1.4,000. You know, you want to make sure that you're clear on what you're creating. So we've got our construction geometric set. We're going to start to build. You know what? I lied. I lied. We have to do more inputs. We have to do more inputs because I want this thing to flex based on kind of proximity. We're going to do some attractor type behavior in this power copy. So back to the inputs. This will be quick. Right click on inputs, define in work object. We're just going to put a couple points on that middle plane. 2 points on the middle plane. 1 point. Okay. And a second point over here. Okay. And we're going to make a line between those 2 points. Press OK. This might come back to haunt us a little bit. We might have to make this a curve instead of a line because of when we input the power copy. We're gonna use a curve as an input, but right now we're assigning this input as a type line. We might have to change it later. I don't know.
Does it need to be behind here?
It can be anywhere. You could make it going through your surface if you wanted to. It's all going to depend. The behavior of the power copy is going to depend on proximity to that line. So rename that line. Proximity line. So inside our power copy, we're going to do some measuring to this line, and it's going to control the length of some other lines. It's going to control the geometry of the surfaces. That's going to trickle down through the power copy. Okay, now our inputs are done. Collapse. Right-click on construction. Define in work object. So let's take a look at this thing. We went through right now, and we, in a little more organized way, we went through the inputs. If I hide the other stuff, I built these lines. All of these lines, kind of in a haphazard way. We're going to do it a little more organized. But basically, we're going to build a wireframe for this panel, and then we're going to make some surfaces, and then we're going to unfold the surfaces, and that's our panel. Inside the power copy, some of the lines are going to be based on relationship. Some of the lengths of these lines are going to be based on the relationship to the other lines. But we'll do that through formulas. So step one, it's kind of hard to see. Maybe it'll be easier if we change the color of that base surface. That is easier. And I have my Z buffer on, which is why I can see these points very well, and I can see through the surface to this line. If I turn off my Z buffer, this button down here, if I turn it off, I can no longer see through that surface. I'm going to leave it on for now because it's easier to pick points on a surface with the Z buffer on. I changed the color by selecting the surface, and then if you don't have your graphics properties visible, right click and select, make sure graphics properties is checked. When they are visible, you can select the surface and yeah, it's almost Valentine's Day, so I chose pink. And I hope my battery doesn't die. We've got time, 38 minutes. Okay, so we're in construction. We're gonna make a line. So go up to the line tool, and we're gonna start to build out the wireframe. Let's make a line, let's make 2 lines. So let's make one from RTPT to RBPT. There's our line number 1. Line number 2 is gonna be the same on the left side, from top to bottom. Direction matters. So if you go from bottom to top, for the first line, go bottom to top for the second line. If you go from top to bottom on the first line, go top to bottom on the second line. So we've got line and line. I would recommend, let's name them. Right click, properties. Remember, if you right click and press O, that's the shortcut to get the properties window up. So right click O. And you call this R base line. On the left, L base line. And now I want to draw 4 other little lines normal to the surface. But I want to be able to change the lengths of those lines later on. So I'm going to make a parameter to control the lengths of those lines. So we want our power copy to contain that parameter. And then we're going to create formulas linked to those parameters to control the lengths of those lines. So we're going to make sure that those formulas also sit within our power copy. So first things first, let's make the parameter. Little f of x button down here. And everybody, I guess I should have said this, I'm in the, I forget, drawing a blank, the geometry workbench, not the architecture and structures workbench. So we are going to make a parameter of type length. New parameter. So make sure you hit the new parameter button. You should have parameters now in the tree. And press OK. Workbenches, start, project center, geometry. It's not going to matter too much. The toolbar on the right is a little different. Toolbar on the left is completely different. But you'll still have the same tools for the most that we're using right now. Yes, yes. So when you're in geometry, press the f of x button down here. It says formula, but you're creating a parameter. Go up to the parameter of type length, new parameter type, length. Press the new parameter of type button, and you'll get parameters in the tree. Length.1, press OK. I'm going to rename this, not length.1, I'm going to rename this corner rise. Enter. And now I want to move this parameter into my power copy. So select parameters right here. Select it in the tree. Control C. Or right click copy. And then right click on PW folded panel, that geometric set. And paste. And now we can delete it from above. Don't delete the whole parameter set, just delete the length parameter. And I'm going to rename this parameters.to. Rename parameters to control parameters. Also, I want my control parameters to happen at the beginning of the geometric set. So I'm going to right click on PW folded panel, object down here, the very last one in that list, reorder children. And I'm going to move control parameters above construction. And this is really just step by step. This is the very beginning of setting up a organized power copy. Right click on PW folded panel, the reordering thing. Go down to the very bottom where it says PW folded panel object, reorder children. It brings up this reorder children window. And there you can grab whatever you want when you want and move it up. No. Press OK. So this is what we have. Now we're going to draw a line normal to the surface. We're going to link the length of that line to that parameter we just created. So line. Make sure we're still in construction. We're going to make a line. We'll go up to our RTPT. It's doing point by point. We need to make sure we're doing normal to surface. The surface is our Valentine's Day surface. Right now you see the direction of that surface is pointing down. We want this line to point out. So reverse direction. And inside end, the end value, right click, edit formula, and we're going to get an error. We're going to get an error because the length of this, the parameter is 0. So all right, let's not do the formula right now. Let's just create the line. Let's create the line 50 inches long. 50, yeah, just change the end to 50. And now let's give this corner rise a value of 2. Corner rise is 2. Now double click on the line again. In the place where we just put 50, right click, edit formula, select the corner rise parameter, and press OK. And our line just got much, much shorter. Right click where you put the 50 inches. Now we have our little f of x formula button so we can go back and edit this when or if we want to. If or when. Flip the, yeah. Let's name this line RT line. And now we need to, so we name the line, we're going to move that formula down into our power copy so that when we instantiate the power copy, the formula comes with it. So you saw when we made the formula, now we have relations up in our tree. We need to, inside relations, there's a formula. What we're going to do is we're going to, and you have to do it in this order, we're going to copy relations just like we copied parameters. So select relations in the tree, copy, right click, PW folded panel, and paste. Select relations in the tree, copy it, Control C or right click, copy. Right click on PW folded panel and paste.
What do you mean that you have to do it in that order?
You'll see. Because if you expand the original relations, that formula is still there. If you expand relations 2, that formula is there, but it's deactivated. Now we're going to delete the original formula and activate the new one. So delete, right click on that new formula, the deactivated one, go to formula object and activate. There. Now we've relinked that parameter to this formula, to this new formula. I'm going to rename relations.to to relations just so it's consistent. And I'm going to reorder relations underneath control parameters. So right click on PW folded plane, go down to the object, go up to reorder, and move relations above construction. Now a little shortcut. We have one line, we want 3 more, so instead of going through and making the line, making the formula, and linking it to the parameter, if we copy this line inside this geometric set and we paste it, it's going to be pasted with that formula. So if we copy RT line, Control C, and then we right click on construction and press P, right click P, right click P, we have, you saw it's bit some formulas into my relations set. They're not where I want them. I want these relations, these formulas inside my PowerCopy relations set, so I'm going to select them. Select those formulas. Now we right click, selected objects, reorder. Sorry, I'm going quick.
Construction, right-click P.
I copied my RT line, and then I pasted inside construction. And I pasted by right-clicking on construction and going to paste, or pressing P. It's just a shortcut. So I grabbed this line right here, Control C, right-click on construction and press P, right-click P, right-click P, paste, 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 paste. And that made these formulas. Does everybody else have these formulas? Select the formulas, right-click, selected objects, reorder, and we're just going to move them into this relations set in our PowerCopy. So if you select relations, it's going to automatically put it in that set. Press OK. Now they're gone from here and they're down in here. What we're doing is we're encapsulating that relationship inside the PowerCopy. So when we instantiate the PowerCopy, the relationship between the parameter and the line moves with it. If we didn't move the formulas, then the relationship would be an external it would be external of the PowerCopy and would be asked for, because it couldn't. It would be asked for when we instantiate because it couldn't resolve that relationship. The computer, the software would not understand where that formula is. But now that it's encapsulated, the relationship moves with the PowerCopy when it goes from one document to the other.
Where you go to move again one more time?
You select them in the tree, and then you can go down to the object.
How do you reorder?
That's how you do it. If you select them in the tree, selected objects, reorder, and then select the relations in the PowerCopy, and say OK.
So if I want to reorder relations above construction.
Then you right-click on PW folder panel, go down to Object, and reorder children. So we need to rename these lines, and we need to put them on different points. So RT point is going to become RB point. So just double-click on that and change the point to RB and rename. So now we have RB line. I'm going to rename this one first so I don't get lost. LB line and then LT line. LB line is going to be based on the LB point. LT line is going to be based on the LT point. And now we've got the basic outline for our wireframe.
Oh, wait, is it okay if I have
it's not going to do the same thing when you instantiate. The reason we're doing left and right is because we're going to create an opening at the top and the bottom. So when it instantiates, we're going to have an opening at the top and the bottom, and the sides are going to be broken down. If you switch it, you'll have openings on the sides.
Okay.
Sure.
Okay.
You could, I mean, this is just a framework. You could do whatever you wanted,
Yeah.
as long as you keep the logic the same.
Yeah.
Okay, so now we're going to put points at the end of each of these lines. So, point, line, ratio. You see the direction of this line is facing down. We want it to be the reverse. So reverse direction, ratio 1. Preview. Okay. Well, I'm going in a certain order. I should fix this. So point dot 14. You select the point up in the toolbar. You want to do the point on curve. Curve, I'm going to put this in the same order that I built the line, so it's going to be my RT endpoint. Make sure that the direction of the line is pointing up. If it's pointing down, you can reverse direction. And we're going to put this at ratio 1. Okay? I'm going to rename this RT underscore P underscore end underscore point. And now I'm going to do the same copy paste. Three times, put them at the end of those lines. Yeah, so copy, right click P, right click P, right click P. I'm going to rename RT to RB, LB, LT, whoops. LB.
So the ratio is just 1.
Yes. And now we can see how this works. Why don't we take a moment to test it? Why don't we take a moment to save first? Control S to save, or file save. We can take a moment to test this by grabbing our reference point and moving it around. Great. It's predictable. It's doing what we want it to do. We can change the control parameter from 2 to 4. Perfect. It's predictable and doing what we want. One thing that we find, if we go to 0, we're going to probably get an error. Yep, we got an error because we can't make a line of 0 length. If we wanted to fix that, because sometimes we are going to have 0 values, we could put a little minimum statement inside the formula that says, if corner rise is 0, set the length of this line equal to 0.00000001. You don't need to do this right now, but I'll show you how that looks in our formula. There's a little math section down here where we want to grab the minimum value, the maximum value between 2. So if I click max in here, and I set that to 0.000001 inches, it's going to report the larger of these two values in this formula. So if corner rise goes to 0, the length of the line is going to be 0.00000001. If control rise value is ever greater than 0.000001, it's going to return that value. I'll do this quickly for each of these parameters, each of these formulas. Okay, so I tweaked the parameters now, so the formulas now, so if this goes to 0, Oh, 0.00001 is beyond tolerance. It rounds down to 0. To illustrate my point, I'll do 0.1 because I know that'll work. There. So now the length of my line is 0.01 because this value is smaller than 0.01. If I go 0.101, the value is 0.101. If I go to 0.09, the value is 0.1. Okay. Side tangent, sorry. Now we're going to put a bottom, now we're going to do bottom lines. We're going to do a line from these endpoints down at the bottom and up at the top. I'm going to start at the top. So make a point, and I'm going to go from left to right. So left endpoint to right endpoint. Okay? And then I'm going to put another line from along the bottom. Bottom left to bottom right. Let's call this, I'm just going to be simple, top line, bottom line. Top line, bottom line. And now we're going to put a midpoint, a point at the middle of each of those lines. So point, select that line, and ratio is 0.5. And we're going to call it top, mid, point. Make a new point, not on the surface. On the curve, ratio 0.5, bot midpoint. And now I'm gonna hide this reference point because I'm tempted to use it in my power copy, and I don't want to use it in my power copy. So I'm gonna hide that reference point so that I'm not tempted to use it. And I'm gonna make a line, a diagonal line from bottom right to top left. Bottom right, top left. I'm gonna call this base diagonal line. Base diag line. And I'm going to put a point at the middle of that. This is just one way to create a center point. There are many other ways to create a center point. Center of gravity, defining a point by a formula. You know what, let's do that. Why shouldn't we? So we just created a point on this diagonal line. Let's rename this point cent point, because this is like our centroid point, our center point. And right now the point is created on the line. But we want to create it as a center of gravity between a couple of lines. So we're going to define it as a parameter, or by a formula. So right-click, cent point object, isolate. And what we just did is we made it a datum feature. It right now does not it's not parametric anymore. We just isolated it from the rest of the model. Its only definition is by coordinates and space that are frozen. We're going to define the point through a formula. So click on formula, the formula button. Select the point in the tree and say add formula. Now we want, since we're dealing with a point, we're going to drag down in our dictionary, we're going to go down to point constructors, and we're going to make a point by center of gravity. So dictionary, point constructor, double click on center of gravity, it'll bring it up here. We're going to make it the center of gravity between these two lines. So select the right line in the tree, sorry, in the model or in the tree, comma, select the other line, press OK, and now it's asking, do you want this formula to really define this object? And yes, I do. Now the point is defined by a formula, and when I hit OK, that point is going to be floating in space as the center of gravity of those two lines.
How do you apply the formula to that point?
If you select formula and select the point in the tree and then say add formula. Add formula, and now it'll give you this window. You scroll down to the point constructors,
Okay.
double click on center of gravity and select the lines. Make sure the lines are separated by a comma. Press OK. Okay, we're close. We're real close. But remember, the formula was created outside of the power copy. So we need to move this formula into our power copy. So go up to the formula, right click, formula object, reorder, and stick it into the relations. Okay. And since we're moving fast, if you guys miss a step here or there, that's okay. I'll give you this for Thursday. But try to keep up.
We delete the old formula out of this.
Hmm?
We delete the old formula.
You don't have to delete. The only time you need to copy, paste, delete, and activate is the very first time you're moving the relations into the power copy. Once you have them, you can just reorder the formulas.
Right.
Okay, so now we've got this kind of base, we've got our point. We're going to make one central line, and that line, the length of that line is going to be based on a formula and its proximity to this line. So that's where we're going to start to get some behavior into the power copy that we're not controlling explicitly. So make a line. We're going to make the line normal to the surface again. Select the surface. The point is going to be our center of gravity point, and so now it's important that the reference point was hidden so you don't accidentally select that one instead. We want to make sure our central point, our centroid point, is selected. Reverse direction so that it's pointing out. And we're going to make a formula for the end length. So right-click in formula, edit formula, or right-click in length, edit formula. And we're going to measure the distance to the line. When we go to select the distance function, it's going to find the closest distance to the line. So we're not going to say max distance, min distance. We're going to say just distance. If we scroll down in dictionary, there's measures, and there's distance, the first one there. So double click on distance. We're going to measure the distance between the central point and the line. Now, one thing we're going to find is that if we're really far away, that line's going to get really, really, really long. So maybe we want to define a maximum length, maybe we want to define a minimum length, and then we want to define a ratio of the distance to that line. For now, let's keep it simple. We'll just say times 0.01. Yes, we want this formula to define the length. 0.24, that's a little too much. Sorry, we're gonna make it 0.1. For now, we'll tweak it later. Press OK. Let's very quickly make that maximum value because I'm not so sure I'm totally satisfied. How we're going to do that, the quick shortcut to making a new parameter. Select corner rise in the tree, copy, Control C, and right click on corner parameters. I'll take that, please. And paste. Now we have corner rise dot one. Thank you. Does everybody have that? Did the copy paste? Right click on it, and we'll call this maximum height. I'm just going to call it max height. I'm going to make it 10 inches. Remember, we made the length based on a formula. The formula's up here, so let's move that formula. Reorder, into relations, OK. Double click on the line. Just like I made the length of the end lines, those corner lines, minimum of the parameter and 0.0, 0.1. We're going to make this the max of either that value or the distance to the line. So we go to math, scroll down, we're going to make max here. Double click on max. Delete the comma and the end parentheses. So it's max parentheses distance times point. I'm going to delete the times 0.1 and replace it with a comma. Select max height and close parentheses. Max between the distance of the point in the line and my parameter. If I press OK, no, I wanted min. Sorry. Min. You can change it just by hand. There. So now I'm at 10. Play with the formula. Get it to act how you want. I'm still not so satisfied with that. Okay. Either way, 10 is a little too big. We're going to make it 5. There. Everybody has something like this. Now we're going to make one last point, and that point is going to be at the end of this line. Reverse direction, ratio 1. Okay. I'm losing people, aren't I? We are. Aren't we?
That's right.
I said record. I hit record. I hope I'm recording. I did press record. Yeah, okay. So we've got construction going here. We're going to make a new geometric set. Right click. I'm going to call this wireframe. Wireframe. And now we're going to draw the lines to create the surfaces. We're going to draw a line here and here, here to here. I'm going to hide. We didn't actually use this diagonal line, did we? Because we made the point by center of gravity. So I'm going to delete that diagonal line because it's just in the way. So wireframe. We're going to make a bunch of lines, and since we're running out of time, I'm going to do it quickly. So from bottom right up to midpoint, okay. Bottom left up to my midpoint, okay. Top right, midpoint, okay. Top left, midpoint. Whoa, that's not what I wanted. And 2 more. All right, let me hide construction and see what I've got. From here, I'm going to make some fill surfaces. So I'm going to make a new geometric set. I'm going to call it surfaces. And I'm going to fill between them. So fill around the bottom, just making some triangles. I should have shown that. Yep. Okay, now I've got this little open pyramid. Hide construction, hide wireframe, and I've just got these surfaces. I did not add the brake legs. We're out of time anyway. So I'm just gonna, we'll hold off on that till later. We'll hold off on the unfold until later. I do want to change my ref point and see how this thing is working. That seems to be working all right. And then I'm going to move this line and see where I get. That must be too close. There we go. There's something, I'm not happy with that formula. I need to tweak something to get that formula to work better. But you can see now if we had all kinds of different lines in our model, when we instantiate all of these panels, we're going to get them reacting to the lines in different ways. So we're going to get unique panels at each one of those points. Every panel will start to be unique just based on its relationship to that line within a range. If we were to get rid of that formula, or if we were to modify that formula now, because I'm still not so certain I like it. Oh, I never named it. Line.14 is going to be our central line. If I get rid of that maximum, the minimum, now it's going to update all the time. So as it gets further away, it's going to get really tall. As it gets closer, it's going to get really short. Yeah. We didn't add an unfold to this. That's okay. We didn't add brake legs to it. That's okay. The important thing to know is that it's possible. You can put that stuff into the model. And I think you've kind of seen the benefits of that from the example before class. So I'm going to stop here.